I'm from J1E, and today I'll be presenting the topic called Plant Pigment and Acidic Alkaline. What is a plant pigment? A plant pigment is any type of colored substance produced by a plant. Most of them can change color when exposed to acidic or alkaline. Why does the color change? The color changes because many plants have a pigment called anthocyanin. So, I did an experiment to investigate whether the plant pigment can color change. Step 1. Prepare the materials. I use plant pigment from red cabbage, vinegar for acidic substance, and baking soda for alkaline substance. Step 2. Boil red cabbage to extract pigment. Step 3. Pour red cabbage juice to 2 glasses. Let's see what happens. From the experiment results show, the red cabbage juice changed to red when mixed with vinegar. The red cabbage juice changed to green when mixed with baking soda, meaning that the acidic substances will turn red when mixed with plant pigment. The alkaline substances will turn green to blue when mixed with plant pigment. After this experiment, I wondered if I can create the litmus paper at home. I did another experiment to create litmus paper from plant pigment. Step 1. Prepare the materials. Step 2. I boiled the red cabbage to extract pigment. Step 3. Soak coffee filter paper into red cabbage juice. Step 4. Dry the paper. Step 5. Cut the paper. Step 6. Separate the acidic substances and alkaline substances group. Let's test the litmus paper. Any color changes? This is the litmus paper I have created, and I am going to be testing this with acidic substances and alkaline substances. For acidic substances, I will be using vinegar, lime, and lemon. For alkaline substances, I'll be using baking soda, toothpaste, and dishwasher detergent. Result shows the paper changed red for acidic substances group, green to blue for alkaline group. The conclusion: by soaking the paper with red cabbage pigment, I can create litmus paper which can be tested for acidic or alkaline. I would like to use various plants to create litmus paper next time. Thank you very much.
Bye, 儿子们，拜拜拜拜。
Hi, I'm Harold Pang from class J2H. Today, I will be explaining about why the needle of a compass always points in a north-south direction. Why, you may ask? It is actually pretty simple. This occurrence is caused by the Earth's magnetism. Earth produces a magnetic field called the geomagnetic field, and therefore the Earth behaves like a gigantic magnet. The geomagnetic field is a zone where the force is active along imaginary lines. From the south to north magnetic pole, this invisible force affects all kinds of magnetized objects on Earth, including the needle in a compass. This makes a compass always point towards the north magnetic pole. Let's do a simple experiment. The experiment shown is to prove that magnetized object is indeed affected by the Earth's geomagnetic field. The required materials are a bucket filled with water, needle, polystyrene or sponges, and a compass. As you can see, no matter what you do, the needle will always point back to the north-south direction. This experiment has successfully proved that magnetized objects is indeed affected by the Earth's geomagnetic field. And that's where I will leave this off. Thank you for your attention.
Good day, teacher. I'm Isaac Wankai, number 39 of Tsin. Today, my science project is on the research about the reaction between a paper straw and a soda. One day, I saw a video on the internet like this. So we're gonna try the experiment on our own. So as you can see, we have our paper straw and our Coca-Cola. Let's try. As you can see, overflowing. Know that soft drinks are made up of H2O water plus CO2 carbon dioxide equals to H2CO3, which is carbonic acid. So when the paper straw absorbs the water in the soft drinks, the concentration of the carbon dioxide is increased, hence producing more bubbles that will overflow due to expansion. This experiment will further prove and compare that different strengths of water absorption abilities will affect the numbers of bubbles produced. So we have 3 containers here, and we will be pouring the same amount of soft drinks into each container. We will wait for the bubbles inside to settle. Okay, now that the bubbles have settled, now we can put our plastic straw inside the first container. As you can see, there are not really any noticeable bubbles formed. Now we will put our A4 wallpaper rolled into a straw shape into this container. And as you can see, there are bubbles produced around the A4 paper. And lastly, we will put the most absorbent amongst all, which is the tissue paper. Now we put it in, and as you can see, there are many bubbles produced around. So this experiment, in conclusion, the better the absorption of material when in contact with a soda, the more bubbles produced. Another way of explaining this phenomenon is the surface of a paper straw is actually rougher than that of the plastic straw. So when the surface is rough, there are a lot of uneven spots, and bubbles will produce between those uneven spots. So lastly, I want to say is, although the paper straws are very eco-friendly, but it's not applicable on all beverages. So in the future, we can either improve on the paper straw making or invent another straw that is eco-friendly and also applicable to all kinds of beverages. Thank you for your time.
Hi teacher, my name is Huang Jiejia. I'm from class J3H, class number 21. Atmospheric pressure. Atmospheric pressure is the pressure excreted on the surface by the weight of air above that surface in the atmospheric pressure. The standard of atmospheric pressure is 101,325 Pa or 760 mmHg. The magnitude of atmospheric pressure is 1.033 kg per cm square. These are the material that the experiment need: 1 large glass bottle, balloon, lighter or matches, and a bit of paper. This is the experiment video. Please enjoy. Experiment explanation. When you first set the water balloon on the top of the glass bottle, the air pressure outside the glass bottle and the air pressure inside the glass bottle are the same. As the fire burns, air heated by the fire rises and pushes its way out of the glass bottle. When a water balloon is placed over the top, the fire will run out of oxygen and extinguish. The air will cool and contract. When the air inside the glass bottle cools down, the pressure inside the glass bottle will be lower than in the surrounding. Therefore, the atmospheric pressure will push the water balloon into the glass bottle. Thank you. Thank you for listening to my presentation. Thank you.
Have you ever wondered how trumpets, despite only having 3 buttons, can play such high notes, or how violins can reach high notes despite having such short strings? These phenomena can be explained by the harmonic series. According to Wikipedia, a harmonic series, also known as the overtone series, is a sequence of frequencies, musical tones, or pure tones, in which each frequency is an integer multiple of a fundamental. But what does this mean? And what does it have to do with music? Well, in this video, we'll be answering all these questions and more. First, we'll start with the basics. How do musical instruments produce sound? They do it by producing sound waves which travel through the air and reach the audience. The sound waves can be produced in many ways, such as by vibrating a column of air, strings, membranes, the instrument itself, or even by electronic means. The waves that are directly generated by these instruments have a unique property. The peaks of the wave are not traveling along the string. This is called a standing wave or a stationary wave. It is created by generating a wave with just the right frequency in which the combination of the constructive interference and destructive interference of a wave in one direction and the reflection of it in the other direction, as shown in the following animation. As you can see, certain points in this resultant wave do not move at all. These points are called nodes, whereas the points where the wave vibrates at maximum amplitude are called antinodes. Let's take a violin string for example. When this string is plucked, we can hear that a G, or 196 Hz, is generated. However, there are actually many other tones produced alongside it that our ears fail to catch. All of these tones are called harmonics. The first harmonic, or the fundamental frequency, has the lowest frequency and the longest wavelength. It has 2 nodes and 1 antinode. Therefore, in order to find out other tones, or sound waves, that can be produced on the string, more nodes and antinodes can be added. For example, a wave with 3 nodes and 2 antinodes will form the second harmonic, or the first overtone. We can also see that it has half the wavelength and twice the frequency of the first harmonic. This process can be repeated exponentially to find waves with 1/3 the wavelength and 3 times the frequency, 1/4 of the wavelength and 4 times the frequency, and so on. Although only the first few frequencies are audible, according to Benward's and Saker's musics, in theory and practice, since the fundamental is the lowest frequency, it is also perceived as the loudest. The ear identifies it as the specific pitch of the musical tone. The individual harmonics are not heard separately but are blended together by the ear into a single tone. As a result, it is the combination of all these harmonics at different amplitudes that determine an instrument's timbre, or character. In many musical instruments, it is possible to play the upper harmonics without the fundamental note being present. For string instruments, it is used to generate a unique whistle-like sound that adds color to one's performance. The technique is done by lightly touching an exact part of the string, which acts as an additional note on the string. For woodwind and brass instruments, the musician changes their mouth shape, or embouchure, to increase the frequency of the sound waves in proportion to the fundamental tone. This technique is used by the musician to reach higher notes. Harmonics are the basis of our tuning system. The intervals between each note are almost the same as the ratio of harmonics. This is also why certain chords sound appealing to us, and this is because the sound waves are in ratio to each other. In conclusion, science can be found in every aspect in our lives, even music. We hope that this presentation was informative and eye-opening.
Hi, my name is Nicole Liu.
Hi, my name is Erica Chu.
Hi, my name is Ng Shiyuan.
topic of our research is the Bombay blood group. We are now going to talk about the Bombay blood group's incidence, discovery, characteristics, and also did research on the blood transfusions, genetics, and diseases related to the Bombay blood group. So what is the Bombay blood group? The Bombay blood group, also known as the HH blood group, is one of the rarest blood groups in the world.
So how rare is the Bombay blood group? It's only present in about 4 per million of the human population. But of course, in some places such as Mumbai, occurrence of this blood group is as much as 0.01%. As this blood group is super rare, people with this blood group who needs an urgent blood transfusion might not be able to get it. As you can see here, the shelf life of blood is only 35 to 42 days. So when a blood is demanded, a donor is required immediately.
How Bombay blood group was discovered? In 1952, Dr. Bende, Deshpande and Bhatia published a note in the Lancet about 2 patients who needed blood transfusion. However, none of the blood types known until then worked for them. The moment their blood were mixed together, the blood coagulated or clumped. Here is a picture of Dr. Harish Bende. The 3 doctors tried the blood over 160 donors. At the end, there was one person, Mr. Z, a resident of Bombay, suited the type of both patients X and Y. This donor blood type was then named by Dr. Bende and the others as the Bombay blood type. This is how the Bombay blood group was discovered.
Allow me to explain why the Bombay blood group is different from other blood types. The most distinguishable trait of the Bombay blood group is that it lacks HH antigens. The HH antigens is found in all blood groups except for the Bombay blood group. So what happens if a blood group lacks the HH antigen? Without HH antigens, individuals are unable to make the A antigen and the B antigen, which causes their bodies to produce antibodies that will counteract the antigens.
Well, can individuals that have Bombay blood group receive other types of blood?
The answer is no. Individuals with Bombay blood group cannot receive any other blood types other than their own. This is because receiving blood which contains an antigen which has never been in a patient's own blood causes an immune reaction due to the immune system of a hypothetical receiver producing immunoglobulins not only against antigen A and antigen B, but also against H antigen. To make it easier, the antigen of the donor's red blood cell must be different with the recipient's antibody to prevent coagulation of blood.
This is a picture of Mr. Sridhar, an individual with Bombay blood group. Since the blood group is so rare, he has made it his mission to donate blood whenever he can. And because of that, he has made 45 donations in several cities so far. One of the reasons why the Bombay blood group is rarely detected is because people often mistake it with the O blood group. The usual tests for the ABO blood group system would show them as group O. This is the comparison between the O blood group and the Bombay blood group. As you can see, the O blood coagulates with the H antigen, but Bombay blood group does not.
As I've said earlier, this blood group is extremely rare. Let's find out which individuals have Bombay blood group. This condition mainly occurs in small communities, where close group relational marriages are frequent. But why? As you can see, both parents must carry this gene to transmit this blood type to their children. Examples of small communities are the Romani, Russians, Jewish, and Parsi. And it is thus likely this blood group has common ancestral origins.
Let's have a look at the diseases related to Bombay blood group. There is a disease called hemolytic disease which is related to Bombay blood group. The maternal production of antibody H during pregnancy might cause hemolytic disease in a fetus who did not inherit the mother's Bombay phenotype. That means the fetus has H antigen while the mothers have anti-H antibody. This is a reason that causes hemolytic disease.
However, till this day, cases of hemolytic disease caused in this way have not been described. This may be due to the rarity of Bombay phenotype. But there is also another possibility, which is the immunoglobulin M produced by the immune system of the mother cannot reach the fetus, thus provoking the expected hemolytic disease.
Donate blood and be the reason for a smile on someone's face, as you can save people's life with your own blood.
In conclusion, since the Bombay blood group is usually read as O blood group, we should raise awareness about this rare blood group in order to find more donors in the future and to help people detect their blood types correctly.
Have you ever wondered how lighters light up? I don't mean these old flint lighters, though for your info, it works by rubbing the flint against a sharp edge of a harder material generating sparks. No, I mean these lighters. These lighters are able to light up with a simple, really hard push of a button. Well, today I have an old lighter here, so let's take it apart and see what's in it. So these are the parts of the lighter, and the one we are looking for in particular is this one. This is the piezo igniter. See, in a lighter, when you push down, you're actually pushing down on the piezo igniter here. The force from you pushing is used to compress the spring here. The spring stores all the energy until it reaches a certain threshold. It will release all the energy into a hammer. The hammer hits a crystal in this chamber, typically the crystal is quartz, generating a high voltage through piezoelectricity. At the tip of the lighter, there is a gap between the two wires that brought the high voltage from the piezoigniter. At the tip, you can see that there's a spark gap, and when the crystal is hit, electricity arcs, generating a spark and igniting the field. The piezoelectric effect was found by French physicists Jacques and Pierre Curie in 1880. So, piezoelectricity is the ability of certain materials like quartz crystal to generate an electric charge in response to applied mechanical stress. To understand this, we have to look at its molecular level. The lattice structure of quartz looks something like this. Now if we oriented it this way, we can see these hexagonal shapes. If you recall your chemistry, quartz is made out of silicon and oxygen. Now, the bonds between silicon and oxygen isn't even. We know that oxygen holds onto electrons harder, making it slightly negatively charged, while the silicon is slightly positively charged. Now, think about the average of positive charges, and that point should somewhere be there in the center. Now when we push down on this, you see that the top two silicons move to the side, while the bottom silicon moves up. And also, you can see that the average of positive charges moves up too. Similarly, the average negative charge also moves downward. And so, the positively charges are slightly moved up, while the negative charges are moved down. Thus, a potential difference is created. If we scale it up, the middle is mostly negative, but we can see a region where the positive and negative charges build up. So if we were to wire it, the positively charged side want to pull electrons from the wire, while the slightly positive side repels electrons. If we pull the wires close enough together, the electricity would jump and create a spark.
The life cycle of oleander hawkmoth. The egg usually lasts about 4 days until it hatches, while the larva usually lasts about 19 days. They all have a horn at its rear end. As it grew, the eye spots near its head became more prominent. And notice how its long and thin tail retracts over time. The side of the body starts becoming black. The tail also becomes a bulbous stump. The caterpillars turn browner as the days pass. Soon it turns almost black just before pupating, and the caterpillar isn't as soft anymore. It then starts building a nest by collecting dry leaves and binding it with its web. The pupa stage lasts about 11 days. At first, it's light brown in color and also a bit soft. The cocoon can also move and wriggle around. And as you can see, it turns brown and hard afterwards. The adult stage lasts about 2 weeks until its death. Unfortunately, this one died during hatching. But they all hatch by splitting its cocoon open. The moth has an army green color, and this helps it hide from its prey. Thank you for listening. Goodbye.
Good morning everyone. I'm Joentio from Senior to Tsin. Today I'm going to make a product that is natural, affordable, and eco-friendly. So let's get started. This product is called the Eco Enzyme. Do you know what is an Eco Enzyme? It is a natural product obtained from the fermentation of agricultural waste, such as fruit or vegetable waste. It can be used as a natural fertilizer, pesticide, and biodegradable cleaning agent. Besides that, the Eco Enzyme can be widely used in our daily lives. There are so many benefits, but can I make it at home? The answer is yes, you can. You'll need to prepare 300 grams of fruit waste, 100 grams of brown sugar, 1 teaspoon of yeast, 1 liter of water, and a plastic container. In conclusion, these are the steps to make your own Eco Enzyme cleaner at home. Make the world a better place by start making yours today.
沙巴崇正中学56周年生日快乐！以下是初一琴班几位同学的视频。
嗨，崇正，祝你56周年生日快乐！
崇正中学生日快乐！
崇正，祝你56周年生日快乐！
在此，我祝愿沙巴崇正中学56周年生日快乐！
沙巴崇正中学，我们再次祝你生日快乐！
Hello， 大家好，又是到了崇正以来56周年庆的时候了。我是实验室助理赵立新老师，我在这里也服务了44年。看着学校从一栋校舍发展到今天拥有客联中心、科技大楼等的各项设施，成为一所让莘莘学子引以为荣的大型学校。崇正，我为你喝彩，为你骄傲。
Nama saya Edrilau. Saya ingin mengucapkan terima kasih kepada semua tenaga pengajar SM Tshung dan selamat ulang tahun yang ke-56.
Happy 56th anniversary.
Tshung.
Happy birthday， 母校生日快乐！我是1986年文科毕业生陈振荣，现在居住在香港。在疫情之下，我们都面对着不同的生活挑战。愿崇正儿女有自强不息的精神，鞭策着我们勇敢地去面对，努力地去跨越和解决我们的困难，提高我们的适应能力。虽然我们有地区上的差别和时间上的不同，但是我们都同心为母校祝福，愿母校的发展是更强、更大、更美好。也祝愿在世界各地的崇正儿女们，大家都平安健康。我们一起加油，母校加油，大家加油。
P